So we're going to get started with section 1 from chapter 6, which is all about reading different types of graphs. So circle graphs, bar graphs, and line graphs. Being able to look at the information that's put on the graph and pull the data from it. So if they're asking you how much you see in a certain year, or how, like comparing two different types of data, if they're talking about like daytime to nighttime, like being able to pull the different, like, or the differences between the types of data. So graphs allow us to see information visually. So instead of just a big list of numbers, a lot of times data is used when you're trying to present it so that it's easier for just anybody to understand what's kind of happening in a situation. Because we can look at a whole, like a big data set, and it may not mean a whole lot to us unless we really understand like what happened in that data collecting process. So this is used a lot in marketing, when they're going over like statistics over population growth or anything like that. They might use a graph to kind of show the trends. Even like now with trying to keep track of the data of cases every single day that are reported and all of that stuff, they're using graphs to help put that information out there so that we can look at it and understand what it means. So in order to read a circle, bar, or a line graph, figure out what the title of the graph is to see what kind of information is being shown. Look at the parts to see how they relate to each other and how they relate to the whole thing. And then be able to look at the labels for each piece, because they might talk about something like being broken down into different categories. Like if they're talking about building a house, there's going to be different costs for that. There's going to be costs for like materials. There's going to be costs for labor. There's going to be costs for like building buying the lot, the ground, and all of that. And then use the given parts to calculate additional amounts or percents. So we're going to start with a circle graph. Okay, so I'm going to come in on this a little bit. I know like in your guys' packet, some of those numbers are a little hard to read. So if you want to write next to your circle graph what those numbers are. So this circle graph here has some information. It looks like they're building something or like a development of some sort, because they've got labor costs, material costs, overhead costs, tariff, and then profit. So labor is 130, materials is 125, profit is 50, tariff is 40. Do you guys know what tariff means? Tariff is tax. Okay, so how much they had to pay in tax on things. And then overhead, that could be like a processing fee or something like that the company can't control, something like that. So they're asking a couple of questions here about our graph. The first one says, what percent of the wholesale price is the cost of the labor? So first of all, let's take all those numbers and add them up. So let's do 130 plus 80 plus 40 plus 50 plus 125. Can you guys do that? Someone add those numbers up and tell me like what's the overall total cost of this, or the overall total number that we're working with here? Good. So 425 is the overall price of whatever is being used here. So if I want to figure out what percent of the wholesale price, so the entire price, the 425, is the cost of labor. Think back to those proportions that we did a couple chapters ago. If you're trying to find the percent or the rate, you're putting the portion over the base. So for this one, the portion is the cost of labor, which is 130. And we're putting over the base amount, which is that 425. And then to find percentage, we're going to take that number times 100 to get us a percent. Because if I actually divide that, I'm just going to get a decimal. So then I got to move that decimal place or times 100. And so we're going to get, if we round, 30.6%. So 30.6% of this price is going towards just labor, just the people that are working on the project. Okay, so I want you guys to do part B. Figure out what the percent of the wholesale price would be for just the materials. So you're going to use the same setup. What is just the materials amount? Good, 125. So we divide that by 425, then take it times 100. Anybody have that number? Good, 29.4% of the cost is just for materials. Okay, the last question here says, what would the wholesale price be if there was no tax, no tariff paid on the imported parts? Good, 385. Because what we do is we take the cost, which is at 425, we subtract away the amount that they paid in tax, which is $40. So then it would be 385. All right, so that's kind of the general idea of circle graphs, how they're going to look, kind of how that stuff means or works and how you use that. We're going to go on now to bar graphs. So to read a bar graph, you're comparing at least two or more amounts, and they're using two or more bars to compare them. So depending on what they're trying to compare, there could be multiple bars on the graph that you're looking at. For example, like they might be looking at data in a workplace and they might want to break it down to like age. Okay, so you could have like different bars represent the different ages of workers that they have, and it could be talking about like how many sick days they take, how much are they getting paid, what's their level of education, like those kind of things we could compare across the board. So for this one here, it looks like these bars are talking about 100 million barrels per the different years here. So on like the y-axis are the years from 2007 to 2012, and then across the bottom would be the barrels, and it's every single one is 100 million. So like where you see 2, that means 200 million barrels were sold or exported or whatever. So the first one says, how many more 100 million barrels of oil are indicated for the company in 2012 than in 2008? So let's look at the number for 2012. So that's the very bottom one here. So we're almost to 6. We're not quite there. We're about 3/4 of the way through. So I would say that that's probably 5.75 for 2012. And some of that you'll have to estimate. And as long as you're fairly close, it's not a problem. I mean, now if you were saying like 6.75, you're off by a whole number. You're not reading it correctly. What would you guys say was for 2008? 4. So we're doing 5.75 minus 4. And you could put 0.00 behind it if you want to keep the numbers exactly the same. So what's that going to be? Good, 1.75, and this would be million barrels. Okay, so that would be the difference. Yeah, you're right, 100 million. 1.75, 100 million barrels. Okay, part B says, judging from the graph, should the company oil production in 2013 be more or less than 2011? More. Why? Yeah, it looks like over time the graph, like the bars keep getting longer. I haven't seen a single time yet where it's decreased. So it looks like the trend is that it's increasing every single time. So if they asked for justification, you could say more because the graph appears to be increasing. Part C, how many 100 million barrels of oil did the company produce in 2008? We talked about this number already in part A. What's the number? 4. So it'd be 400 million barrels. All right. And that's the gist of a bar graph. The final graph that we're going to talk about is a line graph. So line graphs use one or more lines to show changes in data. This would be used a lot. Like I said, they're using it right now to kind of track data on number of cases that are reported every single day. So that would be like going up and down over time. This could be used to represent like profit for a company. If they have 1 year they sell a lot more, the next year they lose a lot more, those kind of things. So we've got a line graph given here to us, and it's talking about temperature for a patient. And it's over a couple of days. So if you look at the time stamps down here at the bottom, we've got 12 a.m. and then to 8 p.m. and then there's another 12 a.m. to 8 p.m. and so on. So this is actually over a 3-day period. So like right here, these first couple of numbers, this is for day 1. The middle would be for day 2, and then the last set would be for day 3. So if they start asking, like in our questions about what days we're talking about, it might be useful for you guys to kind of draw some dividing lines on your graph to understand when it changes from day to day. So like this one says, on what date and what time of day did the patient's temperature first drop to within 0.2 degrees of normal, which would be 98.6 degrees. So I would first, if you need to, figure out like where's 98.6. So it looks like each one here is going up by 0.2. So we've got 98.2, 0.4, 0.6, 0.8. So 2, 4, 6. So this line right here is the normal range for temperature. I'm not sure if I got that completely straight. It's really hard to see these lines up here. So they want to know which day and time did it drop to within 0.2 degrees. So what day do you guys see it finally getting close to my red line? The second day, because that point right here, that's just one above, so that would be 0.2 degrees above normal body temperature. So this is on day 2 at 4 a.m. if I kind of draw that line down. So I'm going to say day 2 at 4 a.m. Part B says, on which day did the patient's temperature remain within 0.2 of normal? So what day or days did it seem to stay pretty close to that red line? Day 3 and a little bit of day 2, right? Like day 2 is kind of when it first started to go back to normal. So we could say for part B that it probably started on day 2 and it lasted through day 3. Okay, part C says, what was the highest temperature recorded for the patient? So the highest point's right here. 100.2 or 102.2, right? So we would say 102.2 degrees. Yeah, I'm assuming it's in Fahrenheit anyway. They're talking about normal. 98.6 Fahrenheit would be normal for us. That would not be normal if that was in Celsius. You'd be dead. Okay. All right.